Hello everyone. Today we will go over a trigonometry unit, chapter 3.1, the tangent ratio. Let's go over the vocabulary first. Alright, so hypotenuse is a side opposite to the right angle in the right triangle, which is the longest side of a right triangle. Opposite side is a side across from the acute angle being considered in a right triangle, and we will definitely go over these with the example and the diagram, so don't worry. Adjacent side is the side that forms one of the arms of the acute angle being considered in the right triangle, but it is not a hypotenuse. Tangent ratio is the ratio of length of the opposite side to the length of the adjacent side. Okay, so usually tangent ratio, actually not usually, every time, tangent ratio is represented in a fraction form. Let's take a look at example 1. We are given our angle, theta, right here, and angle theta right here. So depending on the position of the angle, the name of the sides changes. So previously we talked about what the opposite side here would be. I'll just label it as pink. Opposite side is the side that's opposite to the angle we're looking at. This side over here is called opposite side, whereas adjacent side would be the side that forms one of the arm of the acute angle. By the way, acute means it's under 90 degrees. So in this case, it will be the theta. And theta is an acute angle, so the arm that touches the angle will be this side. That is, and then because it's not a hypotenuse, we need to make sure that we leave that alone. Adjacent side. And then the longest side of a right triangle is always called hypotenuse. All right, so now let's take a look at the second triangle here. Our theta is now on the top left corner. So the position of our angle given is different. So let's take a look at the opposite side. Opposite side to the angle here will be this one right here. Opposite side here. Adjacent is the side that touches the angle. So right this side, adjacent, that is not hypotenuse. And hypotenuse is the longest side of a right triangle. Here. All right, so we do need to understand the sides are relative to the given angle. So depending on where the theta is, your name of the sides will change. So make sure to understand which side is called opposite and adjacent. Now let's take a look at tangent ratio. We were given the right triangle, and let's label some of the sides. First, we do have to label which angle we'll consider first. So I'd consider this, and I'd call it angle A. And the side that's opposite to the angle A would be opposite, and I'll abbreviate it. And there's adjacent side right here, and hypotenuse is the longest side of the right triangle. Okay, now that we have set it up, we have one angle with 3 different sides. Let's take a look at the ratio. So tangent of A, so angle A, is equal to length of side opposite to angle A, which would be the opposite side, and over length of the side adjacent to angle A would be the adjacent side, which is the bottom length right here. So tangent ratio is a ratio between the length of the opposite side over length of adjacent side. So we can actually shorten that up and say tan of A equals to opposite over adjacent. Or you can also write tan A equals to O over A. Moving on to example 2. Calculate the tangent ratio of the opposite side to the adjacent side. All right, so our theta and alpha, the angles, are given to us. So depending on which angle we're talking about, we will have a different ratio or value of the ratio. All right, so let's first set up our triangle. We were given this right triangle here with this side 2. The length of this side is equal to 2, and the length of this side is equal to 3. But before we use these values, we first need to name the sides. I will name the side with blue pen for angle theta. Okay, so this is our angle theta. The opposite side to the angle theta is here, opposite. And longest side is hypotenuse. And the side that touches the angle is called adjacent. All right, so let's fill in our tangent theta first. So we know it's opposite over adjacent. So the ratio becomes opposite is 3, adjacent side is 2. So the tangent ratio of theta is 3 over 2. In red, I will write the ratio for tan of alpha. So this is our angle alpha. And the side that's opposite to that angle alpha is called opposite. And the side that touches the angle here is called adjacent. And the longest side of a right triangle is always called hypotenuse. All right, let's take a look. So we have the same setup, but this time our values will be different. The opposite side is actually just 2 for alpha, and the adjacent side is 3. So notice that depending on the angle, your ratio, the value of the ratio will change. Example 3. Calculate the missing length using tangent ratio. So we're looking for this side, x. We don't have the value for that, but we have the angle, 30 degrees, and we have the value of that one side. And that one side is actually just opposite side. And the longest side of the right triangle is hypotenuse, and the side that touches the angle here is called adjacent. So notice that we are looking for the length of adjacent side. Let's first set up the ratio. So tangent ratio of tan of theta equals to opposite over adjacent. And we'll have to sub in all the values we're given. So we can say that tan of angle theta is 30 degrees, don't forget the unit here, equals to opposite side is 5, and adjacent we don't know, we're looking for that value x. Now we're going to solve for x. What we need to first do is isolate x. And just consider tan of 30 degrees as a constant for now. So treat it together, do not separate them. We're going to multiply x to the entire equation and expand it. Then you should get x times tan of 30 degrees equals 5. And then you're going to divide the entire equation by 30 degrees, tan 30, like that. And we're left with x on the left-hand side and some ratio or some fraction on the right-hand side. And I'll show you how to input this in the calculator using my iPad app. So for this unit, you'll need a scientific calculator. So get used to your own calculator as the input order will be different depending on your calculator or the brands of it. All right, so you will need sine, cos, and tan button there. So we'll start by plugging in 5 divided by, and for my app, I just press 10 button right there and it opens up that bracket automatically and will input the angle 30 degrees. On the right top corner, you'll see a DEG. It stands for degree mode. And make sure your calculator is in the correct mode, because if you're in radian or some other mode, it'll give you a different value and that'll be incorrect. We'll only talk about degree mode for now. All right, so once you're done, you can enter and you'll see 8.660 and so on. So we'll keep it to 2 decimal places. So we have x equals to 8.66. All right, we weren't given the unit, so we don't have to write it. All right, let's take a look at the last part of the section. You can use a tangent ratio to determine the measure of one of the acute angles when the length of both legs in the right triangle are known, as in your opposite and adjacent are known, then you can find the angle, theta. Whereas determine a side length if the measure of one acute angle and the length of one leg of the right triangle are known. Okay, so if you're given an angle, like previous example here, one angle and one side, you can actually solve for the missing side. Okay, so you will need at least 2 properties to solve the missing one. Hypotenuse is not one of the property that you'll need for tangent ratio. All right, so that's it for today. I'll see you guys in the next video.